Hello, everybody. Welcome to the fourth Observe Intelligence podcast. We have a very special guest with us today, Dr. Fred Aminzadeh. He doesn't need any introduction, but I'll still read his bio before getting started. So, Dr. Fred Aminzadeh, he is a professor of petroleum engineering at University of Houston and director of its Artificial Intelligence, Machine Learning, and Data Analytics for Energy Exploration and Production AIM Deep program. He serves on the advisory board of DOE/NETL's SMART initiative. He is also president of FACT. With that being said, Dr. Aminzadeh, it's a pleasure and honor to have you here, and welcome on board.
Thank you, Haas. It's a pleasure to be here, and I'm glad that I have an opportunity to share some thoughts about the important topic of artificial intelligence and data analytics. And I'll be glad to answer any questions you may have.
Yeah. Thank you so much. Thanks so much for doing this podcast with us today. So I have a list of questions prepared. I was going to go through those questions and get your thought process and your vision for the future. So you are one of the pioneers of applications of machine learning in the oil and gas industry. You have published so many books, 15 books to be exact, and more than 400 publications. What is your overall vision regarding the future of machine learning in the oil and gas industry? And are we going to see a drastic change in the industry in the next 10 years? Or is the technology adoption going to be kind of slow? I know it's a loaded questions with a lot of the different segments.
Certainly. I am very bullish about AI in oil and gas, just to start with. And the answer to your question, whether we'll see an increase, is definitely a yes answer to that question. So I'll just give you an example of, if you looked at the statistics in connection with the number of AI-related papers in SPE's one Petro, we see an order of magnitude increase over the last 10 years in AI-related publications. Mm-hmm. I believe we have only scratched the surface on this up until now. And I suspect over the next 10 years, the increase in the number of those papers will be significantly accelerated. Mm-hmm. And I'll hopefully during this conversation, I'll give you some reasons why I think that's the case.
Got it. So you're pretty bullish on the technology, I think, as a lot of people are, and you see a huge potential in the near future. So how about, I know you've been involved in different projects at different places in the past 30 years. Could you provide us some machine learning applications in the industry that has not yet been tried or tested, but you see a great potential in the next few years?
Certainly. Of course, as I said in the previous segment, I do see a lot of expansion of AI and data analytic. And from here on, since I'm going to repeat this, I'll just call it AIDA for short. Since you're going to see a tremendous amount of expansion of applications of AIDA in many new areas, we will also see increasingly significant changes in the nature of such applications. Many of past reported work may have been somewhat of an academic nature, and much of the future work will focus on more practical applications. As an example, many of the past work with a more academic and theoretical and sometimes esoteric character, mm-hmm. and applied to, let's call it toy problems, okay? Mm-hmm. We will move into addressing more real life and operational problems. So that will be one of the major differences that we'll see over the next 10 years. Among new application areas will be use of AI, DA, subsurface reservoir property visualization for real-time decision making. Okay,
Mhm.
that probably will be one of the biggest thing. As a matter of fact, you mentioned my association with the DOE's NETO, and currently there is a 10-year program called SMART Initiative.
Mhm. Mhm.
And the whole purpose is exactly doing that, how to make real-time visualization platform so that we can use AI and other data analytic techniques to be able to make decisions fast
Mhm.
and near real time or real time decisions. So that is the goal of this 10-year project at the DOE. Other areas that we might see activities would be development of advanced sensors and data collection methods.
Mhm. Mhm.
I'll just give you an example from seismic world, compressive sensing.
Mhm.
You probably know that any typical seismic survey involves several terabytes of data. And
Mhm.
of course, once we collect all this data, we have to do a lot of massaging and maneuvering and so on so that we can get to the bottom of the uh, matter and basically find the nuggets within the data.
Mhm.
So techniques such as compressive sensing really tries to just collect the data that is necessary. And basically AI techniques can tell us what and where to collect the right data, right amount. So this is the crux of the future directions. Just as an example, it will be similar for other applications like in drilling. If you want to predict a drilling kick,
Mhm.
currently we collected the whole data in borehole assembly and then eventually bring the whole borehole assembly to the surface and analyze the data and see where, when, and where how kick might be predicted. And now, of course, we want to see if the subset of that data can be sent to the surface of the surface so that we can do a more real-time analysis rather than waiting for the borehole assembly to come to the surface. So those are a couple of examples of how we're going to use um, real uh, advanced techniques to collect the data that we want, but more smartly. We will also see more effective AI-based geosteering in the drilling process.
Mhm.
Maybe production optimization that can help us do more interesting things and more in an optimum fashion. And maybe also we will see some changes in the efficient and more effective hydraulic fracturing in a safer way.
Mhm.
And of course, most important of all, as you know, recovery factor is an important number. And unfortunately, many fields, the recovery factor is under 40%.
Mhm.
So instead of exploring new areas, we can actually go get more oil if we can improve our recovery factor by, say, even 1%. If in Govar, you can create all the oil that is being produced in California.
Mhm.
Um, so I think improving recovery factors and being able to extend the life of the oil fields are a couple of other applications of future applications of these methods.
Mhm. Yeah, very good. Thank you so much for, touching on some of the applications. I think I think like you're like right on in terms of the application of, real-time applications that could add a lot of value, like real time. A lot of the operating companies, I think, are getting tired of waiting, a week or two after the occurrence has happened and then taking action, and they're moving towards, what can we do to detect the problem immediately on a real time basis, and then taking action real time. as well as some of the other applications of geosteering, seismic that you actually alluded to. So,
Exactly.
so the next question is like we know that the combining hydraulic fracturing with long lateral and
Horizontal drilling.
multi-stage, exactly, with horizontal like drilling advancements and hydraulic fracturing and like placing so many stages within these horizontal wells, we have moved towards a new era in the unconventional wells. So do you think that AI DA is the next breakthrough after hydraulic fracturing?
I I certainly think so. As you said, over the last 10, 20 years, we have witnessed tremendous success in exploiting shale reservoirs. And we were able to basically turn, for example, in the case of US, a net exporter of oil and gas from being a major importer.
Mhm.
So what many believe, and I happen to be one of those,
Mhm.
that AIDA will make similar transformative changes in the industry,
Mhm.
and this hopefully will happen within the next decade.
Mhm.
And we will reap the benefits of this transformation as we begin to exploit the full benefits of applications of AI and DA in different energy resource extraction.
Mhm. Mhm.
And this will be in the form of ability to explore new frontiers and maybe more efficient drilling and field development, as well as I said earlier, safer and more cost-effective well stimulation.
Mhm.
And of course, many other good things will happen that we have yet to discover.
Mhm. Mhm.
So the bigger and better things are yet to come.
Yeah, yeah, sure, sure. And the next question, I think that like a lot of like the audience have, and like they always get confused about a lot of different terminologies being thrown around, right? We talk about AI, then you have machine learning, and then these days they talk about deep learning. So could you please break it down for us? In terms of what is the difference between AI, machine learning, and then deep learning?
Well, I think as you know, we have really seen a very fast-paced adoption of AI techniques in general in our industry, and we are bound to have some confusion.
Mhm.
Many people use AI, machine learning, and deep learning so almost interchangeably,
Mhm.
and that's okay. I mean that's understandable and it's okay. But what I like to do is to offer some distinctions, which basically I can start with saying that AI in general, you can think of AI as the universe of all the science and engineering making intelligence machines. So
Mhm.
that is basically AI, especially computer programs.
Mhm. Mhm.
Okay, so machine learning can be considered as a subset of AI,
Mhm.
and machine learning basically provides systems the ability to learn and it basically improve from experience.
Mhm.
Without explicitly basically bringing program to having the programs, computer programs to do so.
Mhm.
I'll just give you an example. If you look at some data, for example, a bucket of say colored balls,
Mhm.
you can just look at the whole bucket and basically get some quick feeling. Just examining the data, eyeballing it, you
Mhm.
can make some conclusions. You can say that, yeah, about 20% of the balls are red, or
Mhm.
10% of them are black, whatever.
Mhm.
So that is, you're eyeballing the data, gives you some insight into what the data is telling you.
Mhm.
And machine learning actually basically formalizes that whole concept
Mhm.
and make it easier to understand and learn from the data.
Mhm.
Okay.
Mhm.
Now, deep learning goes one step beyond that
Mhm.
and basically tries to come up with some understanding of the features of the data. So what the data is telling us, not only it telling us something, but what are the specific characteristics and features of the data. And these things have been used in oil and gas applications but if you just want to make it very simplistic, we can say that AI is the universe, ML is a subset of AI, and deep learning is a subset of ML. So that's a very simplified version of explaining what I just said.
Got it. Got it. So speaking of deep learning, like I know a lot of the like executives from very big organizations such as Amazon. You kind of hear like, for example, the ex Google CEO Eric Schmidt talking about deep learning. Mark Zuckerberg talking about deep learning. Um, a lot of these industries, like especially the tech industry, is very bullish on the applications of deep learning. And I think the reason for that is because you have a lot of data now. We have the application of TensorFlow, and also we have GPU now, like GPU computing that allows deep learning models to be deployed. So what are your thoughts on different algorithms, such as, for example, a recurrent neural network, like for time series analysis, or convolutional neural network for image and text, like classification and so on and so forth?
Yeah, I think that's a fair comment about the level of interest that has been shown within the high technology companies. But it's not just a simple pure interest. They actually are using them. Like Facebook is an example. A lot of data mining that is being done in the Facebook world, whether for advertising or for politics or many other reasons, they actually go and quote unquote mine the data and try to learn much more than what it meets the eye as far as what the data is telling us.
Mhm.
And as I said earlier, deep learning, for example, primarily differentiates itself from other machine learning techniques by focusing on the features that a data set might have.
Mhm.
Uh, so there are many types of neural networks within the world of deep learning and recurrent neural network as well as CNN are some types of those which really perform feature extraction from the data. And this happens through a multitude of so-called hidden layers in their respective neural networks that allows easier feature extraction. I mean, any type of neural network, you can do feature extraction, but these are designed in a way that it makes it easier to do so. And in fact, the particular type of so-called multi-layered perceptrons, or MLP,
Mhm.
those are the building blocks of these RNN and CNN and similar type machines that can help us do that. Now, uh, currently there are many applications. Actually, people have tried these RNN and CNN in oil and gas,
Mhm.
and some of them. So I'll just give you a couple of examples.
Sure.
If you try to see from the data, mostly from seismic data or core data,
Mhm.
the geologic features that we want to see, okay, what are the geologic features, or as we call it, facies, geologic facies that we can extract from this. And then this RNN is a very good vehicle to do that. The same is true with so-called seismic inversion and permeability prediction. Those are some of the things that have been applied, as I said, currently in a somewhat limited fashion. It's not a household that every toolbox may have that in the oil and gas industry, but I expect this to become a more of a sort of part of the normal toolboxes that we use in our activities.
Mhm.
Now, it is interesting that you mentioned Google and Facebook and others. These companies, I know that many of them actually are doing some work with the oil and gas industries so that they can retool their current toolboxes so that it is more applicable to our applications.
Mhm. Mhm.
Similarly, they're also hiring some oil and gas people, or you can call it domain experts,
Mhm.
so that they can bring some knowledge so that they themselves can, with little effort, revise some of their tools so that they can then sell it or apply it to oil and gas problems. So I think you will see maybe some of even your friends or some of our colleagues that used to be working in oil and gas industry are starting to go back and forth between high tech, I call it data science or computing companies, and oil and gas, which is healthy. I think eventually we need to go back and forth and be able to teach each other what are the tools that are needed to be modified in order to solve some of our problems.
Mhm. Sure, sure. And so aside from deep learning and some of the applications that you alluded to, one of the areas that is still new, I think, in the oil and gas industry is the natural language processing, NLP. Uh,
Mhm.
can you explain to the audience kind of a brief definition of what natural language processing is and some of the potential applications within the oil and gas industry?
Yeah, certainly. Basically, the origin of NLP, natural language processing, goes back really to the early 50s,
Mhm.
when the English scientist Alan Turing published his paper on computing machinery and intelligence.
Mhm.
Computing machinery and intelligence. This was one of the pioneering work that basically NLP really what it does is attempts to establish a bridge between formal linguistics concepts and computers.
Mhm.
Uh, so that is basically the origin of it. Later on, late Professor Lotfi Zadeh from Berkeley uh, introduced concepts such as fuzzy logic
Mhm.
and computing with words.
Mhm.
And basically, all of these things are somehow related to NLP and helped popularize some of these concepts.
Mhm. Mhm.
Um, this basically shows that when we are doing some work, some of our work in the oil and gas industry, it's not easily translated into digital topics, concepts.
Mhm.
As an example, if you look at a well log,
Mhm.
especially if you have an old well and someone did some well logs about 40 years ago, and
Mhm.
maybe there's a paper copy of that well log on the wall,
Mhm.
that is really not sort of digital form, and you have to make some sense of it if you want to use that.
Mhm.
Or an observer goes to the field and takes some notes, either looking at the maintenance issue of different wells or things like that, and write some notes. So
Mhm.
those notes have at some point have to be translated into something that usable by computers.
Mhm.
So NLP helps with that.
Mhm.
So as an example, some of the applications that have emerged recently is preventive maintenance of oil pumps
Mhm.
in the field.
Mhm.
So the way it is done is you combine some of the notes that these observers collect as they walk around the oil field,
Mhm.
combine that with digital data as that being collected through edge computing or cloud computing, and
Mhm.
that combination might give you a way to basically see where there might be some problem before even it becomes a problem. Maybe changes in the sound of the well pump, or maybe some vibrations that you hear or other things. So
Mhm.
you can incorporate that information and then go and do some preventive maintenance, and as a result save a lot of time and money before some problem arises. So this is actually one of the applications of NLP, but there has been other applications that people have used for various areas that we deal with, and I think one of them actually is when you go and collect some seismic data, there
Mhm.
might be some observers note that say that this area may have some sort of a washout area, that maybe the coupling of the seismic geophone is not very good, and maybe dead data. So you can combine that information that is linguistic with the actual digital data that you collect, and help quality control the data that you are trying to use for basically creating a subsurface image.
I see. I see. So basically coupling a
Linguistic and more digital data is really the name of the game.
got
And
it.
basically pictures might be part of it, and aerial photos might be part of it. All of these things somehow have to be combined, and NLP can help in those areas.
Got it. Got it. So so now that we talked about deep learning and NLP, like I understand that you recently started a AIM Deep program at the University of Houston, and you are the director of that program. Could you please explain to the audience what AIM Deep is, or the missions of AIM Deep, and how different organizations can actually join this initiative?
Okay. Well, about 2 months ago, we started this program at University of Houston. We call it DEEP. It stands for Artificial Intelligence, Machine Learning, and Data Analytic for Energy Exploration and Production.
Mhm.
Um, I think what we want to happen is to turn this into a unique platform
Mhm.
to help speed up AI DA infusion to
Mhm.
the energy industry.
Mhm.
And, um, and of course, we will do this by bringing the oil and gas operators, oil and gas service companies, and high tech and computer and data science companies, as we was just discussed earlier, as
Mhm.
well as some startups and of course academic groups from not only just University of Houston but other universities. We want to bring all these things, people together, and the idea is we want to accelerate the use of AIDA in the oil and gas, and make sure that we don't repeat the same mistakes 20 times, and learn what are the most important things to focus on for the next, say, 10 years. And, uh, and I like to think of this as a catalyst that breaks down discipline boundaries, because in some companies or even universities, there are a lot of work going on, for example, in data science department, computer science department, geoscience departments, petroleum engineering departments. If you look at the structure of our AIM Deep, it crosses all these discipline boundaries. And I think that will really make it make a lot of good things happen in a very fast way. And the idea is that we have a very fast evolving AIDA in other industries. And to be very frank with you, we are somewhat behind most industries. And we want to basically, rather than reinventing the wheels, we want to make sure that we can get into the action very quickly. So I think you asked how people can join, or how the different organization can join.
Yeah.
Of course, this is an industry-supported program primarily, and potentially in the future government support as well, different DOE funding and other funding mechanisms, state funding perhaps. But basically, we are realizing the fact that right now our industry is not in a very great shape financially, and that's understood. So we have set a very relatively modest goal that we want to have about 10 to 15 sponsors by the first quarter of next year. Mm-hmm. And maybe 3 to 5 computer and high-tech companies, and we have made some progress. And in order to make this thing happen, we are giving some incentives for people, we call it, or groups that we call it early adopters. Mm-hmm. So once it starts a critical mass, then we can move forward and do bigger and better things later on. One main difference between this consortium and many other university consortia is that we don't just have so-called base membership that everyone will get the same result. We have something on top of the base membership, we call it individually sponsored projects. So that if a company has some concern about the data security, and maybe they don't want to share their own knowledge with any other company, we can have a subset of one or more companies to work with us separately on a particular projects of their choice, and I call it ISP membership. So I think this will solve some of the reluctance that, especially major companies that don't want their IP to be shared, or they want exclusive sort of access to the data as well as to the results, and we accommodate them as such.
I see. No, very, very good. And also, for if anybody's interested in participating in this program, what's the best way to get a hold of you? Is it through LinkedIn or?
Well, I hope maybe, now that you think about it, I think maybe my email address could be included in the announcement that you send out.
Sure.
But they can also contact through your if they have access to you. But LinkedIn is another way to do it.
That's sure. Fine. Yeah. I can put your email address, and go from there. Okay. So the next question. Now that we talked about, the applications of machine learning, or AI, machine learning and deep learning and their differences, can we also talk about big data and kind of big data's role in the energy industry in the next, let's just say, 5 to 10 years?
Well, that's actually a very important question. It really goes beyond just the quote unquote big data issue. First, let's see why we are even talking about big data. Mm-hmm. We have seen tremendous increase in the amount of data that are collected. Not only just you look at social media, you look at when you walk on the street and there are some sensors that shows who is doing what. So we really collect a lot of data. And that is the case also for oil and gas industry. We have a lot of data, both to do exploration like seismic and log data, and do production. We collect the data to see how much production we're having. and we also do a lot of um, uh, basically data collection for reservoir monitoring and to see what's happening to our reservoir. So we do collect a lot of data.
Mhm.
And and of course, this is done by sensors and various data acquisition, monitoring, and surveillance tools that we have. Let's just focus on the oil and gas industry.
Sure.
Now, when we talk about big data,
Mhm.
that we don't do enough justice what we mean by just big data. It is not just the volume of the data that is big.
Mhm.
So I can refer you to the 4V concept that is becoming quite a fashionable terminology to use.
Mhm.
And 4V stands for four aspects of big data.
Mhm.
Velocity is this, aside from volume. Volume is, of course, the first one, which is the size of the data,
Mhm.
and comes with the name. But the other three that do not come with the name directly, and that is velocity. How quickly if the data comes, we have to deal with it.
Mhm.
And variety, different types of data, including non-digital data that we just discussed, like text or handwriting or pictures and satellite data, you name it.
Mhm.
Although most of satellite data is all real digital data, but if you just have a picture of the satellite data, then it will become just pictorial data. But anyway, so variety of data, and then another V, I call it veracity, which means that the level of certainty you have on the data, okay?
Mhm.
So these 4V concepts create some challenge.
Mhm.
Not only how to mine the data,
Mhm.
because we eventually need to get to the bottom of things and use all this data to do whatever we want to do in our everyday activities in the oil and gas business.
Mhm.
But also we need to combine different types of data.
Mhm.
Okay, so
Mhm.
mining and integration are two somewhat opposite aspects of where big data plays a role.
Mhm.
Now, obviously, we need this data, since I just discussed that we want to do some real-time analysis and real-time decision-making, we
Mhm.
have to do all these things in a timely fashion. We don't have all the time in the world to get the data, especially if you're doing reservoir monitoring, and go back 2 years later and say, okay, this is how I decide the results are. You may have to do something a matter of few minutes or few days or depending upon the type of operation that you are doing.
Mhm.
And time is money. If you are doing it drilling, you may have some drilling rig that might be $500,000 a day for drilling.
Mhm.
So you don't want to just take your time and stop the operation and analyze the data and go back. So real time is an important thing.
I see.
So we might need to see what are the so-called high performance computing requirements of different work that you are doing.
Mhm.
Okay.
Mhm.
Now, security and cost issues notwithstanding, edge computing and cloud computing might offer some solutions in many cases.
Mhm. I
But
see.
in many other cases, you may need to have high performance computing somewhere accessible. And of course, we can also discuss the potential hybrids between hybrids of high performance computing and cloud computing.
Cloud. Mhm. Mhm.
So the idea is that we need to see what HPC requirements you have to have, both from computing point of view, but more importantly, in my opinion, from memory requirements.
Mhm.
So just last week, I finished a survey in collaboration with NEC, which is one of the largest supercomputing companies in the world. They
Mhm.
have done work in other domains, but not as much work in the oil and gas.
Mhm.
So we want to see, approach different HPC users in the industry and see what are their computing requirements and
Mhm.
which applications needs what.
Mhm.
And I'll be glad actually to send a survey to any one of your audience if they show interest. But the bottom line is basically we handle the data integration issues, especially if you want to focus on real time, with having much larger computers.
Mhm.
And of course, that's the hardware side. Although there are some the boundaries between hardware and software these days are becoming blurry, and that's yet another issue that we don't have time to get into it. But on the software side, I think many AI ideas may help with the solutions to the integration problem,
Mhm. Mhm.
and those integration problem, I like to introduce a concept that I came up with. I call it sure challenge.
Mhm.
Okay.
Mhm.
As we said, we collect different types of data with different nature. There are different animals in most cases,
Mhm.
and the difference. I put together the acronym SURE.
Mhm.
S is the scale. The scale of the data is different. You get the core data from a nanoscale
Mhm.
to field data, the satellite data, several thousand miles.
Mhm.
And that is a scale difference. We have different levels of uncertainty, as we just discussed in big data concept.
Mhm.
We have different resolutions of the data. Some of them can tell you something about what is happening in every inch, and some of them maybe tell you something about happening in 20 meters or 30 meters, like seismic, and
Mhm.
some of them might tell you something about in miles, or maybe several hundreds of meters, gravity data or magnetic data, and so on. So I think that resolution is different. And of course, they come from different environments. So if you put these four letters, S-U-R-E, you will say sure. And this is probably going to be one of the most significant challenges that we will face, to be able to effectively combine these different types of data. And I think AI and DA will play a role in making this happen.
I see.
The last issue that we are going to deal with is making updates of our models in real time.
Mhm.
And I like to think that some approach that we have worked about, called intelligent recursive updating. It's almost like a flight plan. If you're flying from here to anyway, here is California, by the way, Santa Barbara, California, to Texas, you might start with the original flight plan. That's the base. And
Mhm.
then as you are on the sky, you might have to update your flight plan. And if you want to update it to start from scratch, you might take 2 days to maybe update your thing. But the idea is to make minor tweaks to the previous flight plan
Mhm.
based on the new data, for example, the wind speed or direction of the wind, other things that you are on the sky, so that you don't have to start from scratch. You just make intelligence recursive updating. So
Mhm.
this will help doing some of the those updates more in line with real-time applications. And interestingly enough, this G5 concept that is every day you hear from TV, and some different companies are introducing G5, especially for cell phones, but that's not limited to cell phones. So the G5 will revolutionize the amount of data that we can actually download or upload in a reasonably good sort of near real time or real time, so that the speed of transfer of the data will help us to basically do some of this real-time monitoring or forecasting easier to do. And I think that is another toolbox within all the other toolbox we discussed.
I see. Fascinating. Fascinating. Like especially the intelligent recursive updating that you mentioned. That stuff really is fascinating. I think I'm really looking forward to see what the industry is headed next.
By the way, for many of these things I say, I can also share some publications or references so that people, it's not just talking about it, but people have done the work. So I'll be glad to share some of that information if someone is interested.
Sure, we can also put these references and publications right below the video on YouTube, so people have access to it as well. Sure, yeah, that's a good idea. And one more question that a lot of people are concerned about is job losses due to AI. And I think different entrepreneurs and different people have different perspectives on this very issue. I just wanted to kind of hear your vision and your thoughts on, do you think that AI will create more opportunities than job losses in the energy sector?
Well, the quick answer is that I think AI or intelligent machines and data science are really our allies, not our enemies.
Mm-hmm.
Okay.
Mm-hmm.
I think if you go back during last 100 years, we have seen many advances in different aspects of life, from electricity to computers to internet. It is true that they have impacted some nature of some of the jobs.
Sure.
But in all, I think on balance, they don't sort of take away the need that we have for human being to be on top of the whole operation and try to make some sense of all the data and everything that we need to do. So AI is not going to take away people's job,
Mm-hmm.
but it also, however, it provides a challenge.
Mm-hmm.
That we need to be on top of things and we adapt ourselves to the new environment.
Mm-hmm.
So yes, maybe some of the routine things that an engineer used to do some spreadsheet and enter all the data to some spreadsheet, production and so on and so forth. Some of those things could become automated and you don't need that part.
Mm-hmm.
But it's still to be able to make sense of the results, interpret the results, and also write those programs that you need to give the computer, like we just discussed, in natural language processing being one of them. So the nature of the jobs will be different, but I don't think on balance we will lose much, if any, jobs.
Right.
So I think, having said that, we must. So I just said that we have to be equipped to learn new tools and start learning them, and as soon as possible. Starting this spring, I'll be teaching a course at the University of Houston on the use of AI and data analytics for oil and gas applications. So what we want to help, we really, the goal is to train the next generation of petroleum engineers and geoscientists so that they are better equipped to tackle the future challenges that we highlighted.
I see. That's a great initiative. I think, when I graduated from college more than 10 years ago, we didn't have those courses, and I'm glad to kind of hear that you guys are actually moving that route in terms of educating the next generation of petroleum engineers on how to code, how to use Python, how to apply different machine learning algorithms within the energy sector. I think that'd be very useful. So finally, the last question that I have, Dr. Aminzadeh, is any recommendations for data enthusiasts and people who want to kind of get into data science and AI and machine learning, based on your experience, based on your tremendous background that you have in this area. What are some of the recommendations for some of the younger folks getting started?
That's an excellent question. And I'd like to, first of all, the very fact that your audience is listening to this podcast, that's actually a step in the right direction. But what I would strongly recommend, a few things. First, learn the fundamentals and the basics, okay? A solid foundation is critical. Don't just say, okay, I use the word AI, so I am an AI expert, okay? So please try to focus on establishing a solid foundation for whatever technologies that you think you may need. And that brings me my second advice, and that is you need to establish a balance between your focus on the depth and breadth of your knowledge, okay? Let me elaborate. You can know everything about nothing, or you can know nothing about everything. So those are the two extremes. So you have to find the right balance, how much you want to know about what topic and what is needed. And don't be one-dimensional. So try to be more than at least three-dimensional, if not more. So that's the second advice I would have. And my other advice would be try to use all the available resources, okay? I mean, although I understand that there are many, many things to learn, but also with that comes huge amount of resources. Your podcast probably is one such resource, and you didn't have this type of thing 30 years ago.
That's right.
Or internet, or many, many other resources that we have today, we didn't have before. So to make use of those available resources, okay?
Sure.
And also, I emphasize, increase your interactions with others. Don't go just to your apartment or your house in a corner and just try to solve the world's problem on your own. World problems are too complicated to any one person can solve them. So work with other people, teamwork and interaction with other people is absolutely necessary. And of course, networking, something in that area. One other comment I would make is seek mentoring from more experienced people. There's nothing wrong to go and ask questions, and most people will answer. By the same token, offer mentoring to others, newcomers. So don't be stingy with either time or with your, if you share knowledge, you don't lose it, you actually expand it.
Absolutely.
Okay. Yeah. And finally, I will say never stop learning. And hopefully, as you are learning, enjoy doing it. That's my last word.
Yeah. Thank you very much. Very appreciate your perspective, your time today. I learned a lot from this podcast. I hope the audience did as well. At the end, before we finish the podcast, do you have any final words to say, Dr. Aminzadeh, before we finish it?
Well, the only thing I can tell you is this is really a good time to live in. Things are really looking up as far as the amount of new ideas, new technologies. There's no other time in the past that is as good as this time. So enjoy and learn, as I said, and make sure that you are on the right track. And if you are not on the right track, make adjustments. Don't be afraid to make some adjustments.
Yeah, sure. Yeah, thank you very much again. Appreciate your time. Thank you everybody for listening to today's podcast. Hope you enjoyed it. If you liked it, like and share, and subscribe to the channel. Thank you very much.
Thank you.